In this video, you will learn about corner detection in OpenCV. Corners are regions in the image with large variation in intensity in all the directions. There are two types of corner detection method in OpenCV. First, Harris corner detection, and second, Sheath-Tomasi corner detection. Before we go to the code, let's try to understand what we are going to do in this tutorial. We are going to have one image of chessboard. You can see this. This is our original image. And we are going to detect the corner in this image. And once we detect the corner, you will see this blue color dots here. And these dots represents that we have detected corner in our chessboard. Now let's go to the Jupyter notebook and start coding. Let's import CV2, import CV2, import numpy as np, import matplotlib.pyplot as plt percentage matplotlib inline. Now I'm going to read image of chess. I will call this variable chess here, then CV2 imread, and then chess image name flat chess.jpg. Then I'm going to convert this image from BGR to RGB. I'm going to call this variable chess here. Then from CV2 I will call CVT color. Inside this I will pass our chess image variable here, and then CV2 dot color underscore BGR to RGB, and then let us print our image plt.imshowChess. And here in the output you will see this is the flat image of a chessboard, and we are going to detect corner in this image. Now we are going to first convert this image into grayscale. Now I am going to make one variable gray underscore chess, and then I will call here cv2 dot cvt color, and then I will pass here chess, then cv2 dot color underscore, this time bgr to gray, and then let us print our image plt.imshow gray chess, and then color mapping is going to be gray. And we got error here. Okay, this is the reason. I have to eliminate this one. cv2 color underscore bgr. Now we should get it. Here in the output you can see that we got gray image of a chessboard. This is a flat chessboard. Now we are going to read original chessboard. I will copy this from here, and then I will paste it here, and I will make this as chessboard, and here I will give the chessboard image name, and that is going to be chessboard.jpg, and then I will put this here and this here and this one here. Let us execute our code. And this is the original image of chessboard. We are going to detect corner in this image as well, and we are going to convert this also into grayscale. I will copy it from here, and then I will paste it here, and to this one I will name as chessboard, and then this is going to be chessboard, and this I'm going to replace with this one. And here in the output you can see that we got the black and white image of our original chessboard. Now let's see Harris corner detection, how it works. I will call here gray chess, and here in the output you can see these are the values of this gray chess. Now I'm going to convert this from integer to float type for Harris corner detection. I will make one variable float underscore gray underscore chess, and then I will call here np.float32, and it is going to be float 32, and then great chess. Let us execute our code. Let us print this, and here in the output you can see now the data type is float 32 here. Now we are going to make one variable dist, and now we are going to call Harris corner detection method. I will call cv2, then corner detection or corner Harris. So its function name is corner Harris, and then first parameter is source. Source is going to be our source image, and it is going to be float great chess, this one that we have just converted from int to float. And the second parameter is going to be block size, and this is going to be, let's say, 2. The third parameter is going to be case size. This is going to be, let's say, 3, and last one is k. Let's say this is going to be 0.04. So where in this parameter you will see source, this is our input image. Then we have this block size. It is the size of neighborhood considered for corner detection. Then we have this case size. This is parameters of Sobel derivative, and then k size, and then we have this k. So k is for Harris detector free parameter in the equation. Now let us execute our code. Now let us plot this, and for this what I am going to do, I will call our chess, our original image, and then I will do here, I will take this dist, and I will find all the values which are 0.01 into dist.max, and then I will assign them red color. So 0 is for 0, 0, 25, 255. Not red color but blue color. So this is R red, G green, and this is blue, 255. So we will see corner color in blue. And now let us execute our code. And now let's print chess plt.imshow, and here in the output you can see that we are having this corner detected here. So all the blue color dots are nothing but the corner in this flat chessboard, and this corner has been detected correctly. Now let's do similarly for our original image. So what I will do, I will just convert our original image from int to float. I will write here float underscore chessboard, and then I will call here np.float32, and then gray chessboard, and then I will print this. So we have converted it into float 32, and then we have to do the same for our original image as well. And here I just have to pass float chessboard, and then similarly I will copy this line here. So this line is just for visualization that we are doing on the original image. So instead of chess here, I will pass here chessboard, and then plt.imshow chessboard. Because I have forgot one step here, so let's do it for both this flat chessboard and the original one. So I will write here tst is equal to cv2 dot dilate, and then dst none. So if you remember, dilate is a morphological operation that we have already seen in our previous tutorial. I will run this again. So now you can see the dots are big in size and looking good here, and similarly we will do it here as well. And now here in the output you will see we are able to see dots here. So these red color dots, they are very light in color because we have this colored image here. That is why you may not be able to see it, but let me zoom this image. So I hope you will be able to see it now. You can just zoom in and zoom out, so you will see these small red colored dots here. So it has detected corners here in our original chessboard, but in flat chessboard you can see it has detected very accurately here. So this is how you can do corner detection in OpenCV using Harris detection method. I hope you enjoyed this video. If you like my video, you can subscribe to my channel. Thank you for watching.